Welcome back to another explainer. So today we're diving into something absolutely fascinating. We're going to break down this incredibly brilliant environmental science simulation called The Expedition. It was created by Patience Learning. Now, on the surface, it just looks like your standard high school science project. Students play the role of solo field researchers out in the wild. But as we're going to see, what these students think they're doing and what they're actually doing, well, they're two very different things. Okay, let's dive into this. What if a science test was actually a psychology trap? Think about that for a second. Today, we're pulling back the curtain on this whole simulation. Because, see, while the students think they're just out there mapping rocks and testing water, the expedition is actually secretly testing them. It's meticulously designed to put human psychology under intense pressure. It's testing their cognitive biases, their ability to make decisions under deep uncertainty. Honestly, it's an absolute masterclass in educational design. Let's start with Section 1. The Harmon Ridge Survey, or what we can call the surface mission. Right, so for this 9-day solo mission, the students are completely in charge. No internet, no teacher holding their hand. To actually survive out there, they have to constantly juggle 3 key metrics on their dashboard. First up is the data quality score, which basically measures how well they're piecing together a coherent geological picture. Then there's the safety margin, that tracks their physical risk and overall fatigue. And finally, supply efficiency. This one is absolutely crucial. They literally only have 20 batteries, 15 sample containers, and 18 liters of water. And as they explore, those supplies just drain away. If you run out of batteries, boom, your electronic tests stop. Run out of water, you have to evacuate, and your simulation is immediately over. And this brilliantly illustrates the actual game board they're playing on. It features 5 distinct zones, and every single one carries different physical and supply costs. Take Zone A, for example, the creek bed flats. It's super easy terrain, really low cost. But then consider Zone C, the old-growth hollow. It's incredibly steep, so while it's packed with great data, it burns through a ton of water and really beats up your equipment. Or look at Zone D, the abandoned mine site. That one has massive supply costs and elevated safety risks. So the students have to constantly evaluate these areas and ask themselves, okay, where do I actually invest my extremely limited resources? Which brings us to Section 2, the hidden bias traps, otherwise known as the secret curriculum. Now, here is where things get incredibly interesting. Between you and me, the simulation isn't really about collecting environmental data at all. It's a Trojan horse. The whole 9-day experience is specifically architected to trigger human cognitive biases. The game literally wants the students to mess up. It wants them to make bad calls based on flawed human reasoning, just so they can learn to catch themselves doing it. Walk with me chronologically through this timeline of traps that are basically hardwired into the system. On day 2, students get their very first data point. The trap here? Anchoring bias. That first number becomes the mental anchor they just unconsciously compare everything else to. Then, day 4 rolls around. The game feeds them weird, anomalous data that completely contradicts their working theory. This is perfectly placed to trigger confirmation bias. Like, are they going to just ignore the new data to protect their precious theory? By day 5, a massive, super vivid storm hits, triggering the availability heuristic. The storm is just so intense and scary that students usually end up overestimating the weather risk for the rest of the week, so they just hide out in the safe zones and completely miss crucial data. Moving right along to Section 3, red herrings and real science. So the game uses the framing effect by sending this super dramatic radio message from base camp, talking about collapsed structures and toxic contamination. This loaded language is a total lure. It frames the abandoned mine as this thrilling adventure, and it totally draws the students in. They'll spend day after day just testing for contamination. But it's a massive red herring. The contamination is entirely localized. It has absolutely nothing to do with the broader geological story of Harmon Ridge. This distraction, disguised as high-stakes drama, creates 2 very different types of students. On one side, we've got the mine explorer archetype. They totally fall for the drama, fixate on Zone D, burn through half their supplies there, and just end up with terrible data quality because they completely miss the big picture. But on the flip side, we have the systems thinker. This student completely ignores the dramatic framing. Instead, they just do the boring, responsible work of collecting broad baseline data across the creek beds and the meadows. And because they were so methodical about it, their data quality absolutely skyrockets. And that sets us up perfectly for Section 4, the Day 7 pivot. Everything we've talked about so far builds to the absolute climax of the simulation. If you are playing this game, Day 7 is the exact moment your world completely falls apart. This is the big inflection point. Disaster intentionally strikes to separate the methodical planners from the scattered, reactive collectors. You drop your instrument case, boom, Your equipment durability just plummets below 50%. Suddenly, your electronic instruments are completely unreliable, and some of your tests are just totally unavailable, gone. Students are thrown into an absolute panic here. They can try to fix the gear, sure, but that costs a whole day and only has a coin flip 50% success rate. Or they can try to blindly push forward with broken gear. But for those methodical students, the systems thinkers we just talked about, there's actually a hidden third option. Let's move to and see how this builds, because it's just brilliant. If a student collected those broad baselines before their equipment broke, they don't even need the electronics anymore. Actually, scratch that. It's more like they realized the electronics were just a crutch. They can literally just sit in their lab and cross-reference the data they already gathered. And if they do that, they discover the hidden cross-zone correlation. It's like a giant puzzle coming together. They'll notice that the high levels of chromium and nickel in the rocks up at Zone B, well, they perfectly match the dissolved minerals in the spring water all the way down at Zone E, which then perfectly matches the sediment in the creek at Zone A. They realize the entire landscape is connected. It's all just one single weathering event echoing through the entire watershed. How cool is that? All right, Section 5, grading the invisible path. Discovering that hidden pathway honestly feels incredible for the students. Now, what's really interesting about this slide is the profound final twist of this whole explainer. Those dashboard metrics the students have been sweating over and obsessing about for 9 days, they are complete and total fake-outs. Seriously, the teacher doesn't grade the data at all. Survey data quality is literally worth 0 points. The entire grade, the whole 36 points, is based purely on a daily journal and a final reflection. See, the teacher is grading the student's reasoning, not their scientific results. A student who finishes with a terrible, abysmal 40% data quality, but writes this brilliant journal explaining exactly why they fell for the sunk cost fallacy or the framing effect, they will actually score a perfect grade. The ultimate destination of this entire simulation is a concept called metacognition, or simply thinking about your thinking. It's this crucial capacity to recognize your own cognitive biases, to question your assumptions, and to really assess the limits of your own knowledge when you're faced with uncertainty. The rubric explicitly rewards honesty, so a student who admits their mistakes, catches their own biases in real time, and says, hey, I actually don't know this, totally outscores a student who tries to fake it and presents this overly polished, perfectly fake narrative just to hide their errors. So the crucial point is summarized perfectly right here in the teacher's guide for the simulation. It says, the biases are the vehicle. The capacities are the destination. I just love that. The goal was absolutely never to just memorize a bunch of rock types. The true goal was to build these durable habits of mind, right? Building the capacity to navigate deep uncertainty, to recover when you inevitably fail, and to separate your emotional, knee-jerk reactions from rational, hard data. It really makes you think about your own daily decisions, doesn't it? I mean, whether we're talking about science, business, or just everyday life, we are all operating with limited supplies and incomplete data. So I'm going to leave you with this provocative thought. If your instruments broke tomorrow and all the shiny systems you rely on suddenly failed, would the boring, responsible baselines you've built be enough to save you? Think about it. Thanks so much for joining me on this explainer, and keep learning.